So today we're going to take you through our managed Corda service on Kaleido. This is a very apt title, build a Corda business network in minutes, not months. So end to end, we're going to start from scratch and should take roughly 15 to 17 minutes to stand up all the components and actually instantiate and drive our core dev. So pretty appropriate title. Have a few slides to go through and then we'll dive right into it. So at a very high level, there's kind of three tenets that encapsulate Kaleido. Built for modern business networks, so we're completely industry use case agnostic. We're providing the componentry, the runtime, the core services, and these are extensible to financial services, supply chain, healthcare, pharmaceuticals, retail, entertainment, you name it. You can build and solve any use case or solution on the platform. Number two, radically simple. You'll notice this throughout the user interface, but behind the scenes, there's also a very simple, clean REST API for every action that we're performing at an administrative level or at a programmatic or at a service level. And then the third, really important, built for the enterprise. So you get these high levels of high availability, disaster recovery, auto scaling, best of breed, public key infrastructure and key management. You get these out of the box on Kaleido. And even on our free starter tiers, you're going to get these high levels of availability and DR as well. So our approach really is to flatten the curve, try to make it as streamlined and as quick as possible to transition from wrapping your head around this technology at an early POC stage, transitioning to a pilot to prove out the viability of your solution and your use case, and then ultimately to get into production. You don't have to bother yourselves with maintaining the network, with operating and standing up all of the core components, the really hard technical things. Kaleido does all that on your behalf, so you can focus your attention on the things that really matter, which are the business logic and then a nice interface for your end users and your customers. One thing that's become abundantly clear to us over the last 18 to 24 to 36 months as we've worked with a really extensive array of clients and built out these production solutions is that the blockchain, the smart contracts, the consensus algorithm, the nodes, it's really important, right? That's our ledger, that's our trust anchor, but it's a kind of a drop in the bucket in terms of the overall application stack. We see blockchain as being maybe only 5 to 10 to 15% in a lot of these solutions. And there's a lot of things that you need to build into your solution. You need to answer questions around data. You need to have different transactional components for public and private transactions and the ability for your application to reliably consume events. You need rich integration tiers to your existing legacy systems and your back office processes. And then you need easy buttons around the application layer, RESTful interfaces and digital asset constructs. So within our Ethereum ecosystem in Kaleido, we've provided these all as first-class citizens directly embedded into the platform. And moving forward, you're going to start seeing a lot of these become available inside of Corda as well. This is just a quick snapshot of a few of the clients that we have running in production on the platform. So gives you a taste of really how extensive and how diverse the ecosystem is. And then lastly, just a few snapshots on what you get when we say enterprise grade. So ISO 27001 certification, really high caliber secure key management techniques, enterprise identity constructs with PKI and X509 certificates, HADR, business continuity with reliable snapshot backups, and then just best of breed open source clients as well. I'm not going to go ad nauseum on these, but I think it's worth mentioning that you truly do have enterprise out of the box, regardless of what plan you're on in Kaleido. So that's it for the slides. One more piece of housekeeping. This is recorded. You'll receive an email with the recording of this demo. But we've been doing these for about 8 months now as well. We've done these, for Corda, but we've done a lot of them for sort of the Ethereum door inside of Kaleido. So if you are interested in, any of those, I guess, ancillary services that I touched on, or actually want to see some turnkey applications and real world demos, encourage you to go to, just the Kaleido YouTube page, and you have a curated list of all of the videos that have been done in the past. Jim did one on upgradable contracts a few weeks ago, for example. Okay, so without further ado, let's go ahead and hop into it. And everything that I'm going to do in this demo, every single person in attendance is going to be able to do this as well. So I'm going to use the out-of-the-box free starter plan on Kaleido. And what I'm really going to do is just go, step by step through the Corda quick start guide inside of our documentation. So this is a rather lengthy piece of documentation because there are a few steps involved, but I just want to mention that every single person in attendance is going to be able to repeat these steps that I'm taking you through. Okay, so into the product. Need to log in. So again, this is just a free starter account that I've created. And our first call to action is to create our consortium or create our business network. So I'm just going to make one called testnet. I could optionally upload some prose or some rhetoric or legalese for the mission statement. I'm going to forego that. And now I want to choose one of the available cloud providers and underlying regions in Kaleido. And you see that we give you a choice of 4 regions across AWS, all across the globe, and then 2 regions on Microsoft Azure. And what we're essentially doing here is we're whitelisting this cloud provider and whitelisting that underlying region for the containers to be hosted in that data center. So since we're on the East Coast of the States, I'm going to go with AWS in Columbus, Ohio. And since I'm on the free starter plan, I can't truly make this a multi-cloud or a hybrid multi-region network. So we're sticking with one cloud provider in one region. So here's the namespace for my business network. And now I'm going to click on this governance tab here, and I'm going to use the memberships option. So one really nice construct that we've built into Kaleido is the ability to easily mock out what you want your network to look like when you get into production, right? Creating a facsimile of that future production network. And so what you can do is you can mock out, the participation using what we call memberships. And so you could pretend to have multiple banks, multiple financial institutions, insurance carriers, healthcare systems, et cetera. Since I have named my organization Alpha, I'll just create another one called Bravo organization. And what we're going to do in the Corda demo is we're going to do a very, very simple vanilla IOU transaction between Alpha organization and their node, and then Bravo organization as the borrower of an asset. When you do get to the point where you've hardened your application and you know the topology of what you want your network to look like, you can start decentralizing it. So you can use this invite organization option to actually extend invitations and allow autonomous control of resources from external organizations inside of the network. Okay, so here's the namespace, the business network, 2 memberships, and now we want to create our blockchain. We want to create what we call an environment in Kaleido nomenclature. So we see that we have 2 doors to go through. We're going through the Corda door today. So click Corda, click Next, and now we want to create a name for this environment, for this blockchain namespace. So I'll just call this Sandbox. And inside of Kaleido, we've built this, sort of in tandem with classic DevOps pipelines. So inside of your business network, you could have a sandbox dev environment, you could have a pre-prod or a UAT environment, and then ultimately you can have a production environment. We make it very, very easy to promote and progress your code and your application logic through these environments without having throwaway work. So I'm going to go with cloud only since I'm on the free starter plan, and that's my only option. On other plans, we do offer multi-region, multi-cloud, and even support for running these containers, these runtimes, these nodes in a private cloud or in your own on-premise data center. So if that's something that's of interest, please reach out to us and we can discuss that in more detail, take you through the steps and the requirements there. Okay, so I'm going to go with Corda OS, and we're going to go with a managed notary service here. So click Finish, and here's the namespace for our environment. This is just the firewalled namespace. And now we want to bring it to life by creating a couple Corda nodes. So I'm going to create a node for each of our memberships that I have. So create N1 for our Alpha organization. This will be the issuer of the IOU transaction. We're going to skip this step here, but this is sort of emblematic or representative of a lot of the integrations and synergies we provide you with your existing cloud resources, backups, log streams, private traffic, etc. And then I'm just going to go with a small node. Again, on our higher tiered plans, based on the performance you need and based on the horizontal scale of your application, we have different t-shirt sizes that support those requirements. So we'll go ahead and click finish, and then I'll do that same step and I'll create a node for our borrower in the demo. Node number 2, bound to the Bravo organization. Next, next, and click finish. And these guys will take probably 45 to 50 seconds to fully initialize and join the network and then transition to a started phase. And you can always have full line of sight sort of on the status of your resources just by clicking the dashboard tab beneath blockchain here. So while these guys are coming to life, I'll draw your attention to another construct that we have. And this is really nice for network operators or system administrators that want to have that full expansive line of sight into all of the entities and all of the organizations that are operating on the network. So we have this address book here, and you can view all of the memberships inside of the network. And these would include, of course, external organizations if you were to properly decentralize your network and extend an invitation. So we see here that we have our system monitor. This is going to act as our notary. And then we have our 2 organizations, both bound to my root organization, Alpha organization. So you can click on this, view the membership details, see the runtimes associated with it. Nothing terribly exciting here. We just have a node for each membership, and we can see the status there as well. So the address book is it's a very useful utility, becomes even more useful, as the network grows and as the network decentralizes. So we'll hop back down to our dashboard tab, see that we've made good progress here. Node 1, node 2, and the system monitor have all started up. And one important thing that we need to do here before we take actions of restarting or reinitializing our node is we need to let these nodes properly and fully initialize. Essentially what we're looking for is we're looking for a notification in the logs that the node is running in its P2P messaging loop, that it's fully synchronized and that the P2P communication, that those threads are active and that they're happy. And one of the steps that we do need to do is we need to upload some of our business logic, our core dApps, and then we need to restart the nodes so that they can load those core dApps. So anyway, we'll come back to that in a second. So our next step right here is to add a core dApp. And all we're going to do here is we're going to upload our IOU contract and our IOU flow. And then we'll promote those into the active runtime of the node. We'll restart the node and we'll let the node properly load those. So first thing we're going to do here is we're going to create what we call a contract project. So this is just a wrapper or a namespace for our underlying core dApps for our Java code, or in Ethereum, this would be for our Solidity code as well. So I'm going to create a contract project called IOU. And this is a useful construct because it gives the entire business network this full collective shared line of sight into exactly what business logic they're executing, exactly what their apps are talking to. So first thing we're going to do is we're going to go ahead and grab the contract file. Let me just move this zoom bar. It always gets in the way. And these are available. All of these assets are RPC client that's going to drive our application. And then those core jar files, those are available in our public facing GitHub library, which I'll pull up here in a second. So first we want the contract jar. Grab that, click finish, and then we want to go ahead and grab the flow jar as well. So as that guy is loading in there, I'll draw your attention to the Kaleido Corda samples gallery. So this is the first thing that's referenced in the documentation. And like I said, this lets you build the RPC client that's going to sort of drive our transaction calls. And it's going to provide you with that source code, the jar files that we need to actually execute the application. Okay, so now what we want to do is just add that flow file to the IOU project that we created. So again, we'll go back here, Corda demo library, Kaleido Corda samples, and now we'll go into the flow folder. So go into build, go into libs, and there's the flow jar right there. And we'll go ahead and click finish. And now what we need to make sure is before we promote these into the active bucket of the node, into the runtime, into the core container, we need to make sure our node is in its P2P messaging loop. So we'll go ahead and click the logs, and we see that this guy is good. No core dApps have been loaded, and it's running the P2P messaging loop. So let's check on node number 2 as well. Do our due diligence with this guy. So no core dApps and also running the P2P messaging loop. Okay. So now we're going to use this Corda management tab, and we see what we have is we have our contract jar and our flow jar hanging out in the staging bucket of the node. So what we're going to do is we're going to promote these, and then we're going to restart the runtime so it can successfully load those core dApps. So we'll promote, and now we'll restart. And we need to do the exact same thing to node number 2 as well. Node number 2 is going to take part in this IOU transaction. It's going to acknowledge that it's the borrower of 100 arbitrary units that we've configured in the source code. So we'll go to core dApp management for node number 2, and we'll promote both of those as well. And we'll restart this runtime. So as these guys are restarting, what we can do is we can go ahead and provision the other components that we're going to need in this application. Namely, what we need is we need a way to access the TCP port for the Corda node. We're going to need to create what we call a Kaleido bridge or a Kaleido tunneler service. And this is going to allow our RPC client to ultimately have requests proxied into the Corda node and resolve at that TCP layer. There's not a public-facing RPC endpoint that we can access. So we're going to use a service that we've created called a Kaleido bridging technology. And this is the same service, this is the same technology that we actually use with our Kaleido private stack orchestration that I mentioned at the beginning, the ability to fully manage, your own runtime infrastructure in an on-premise data center or in a private cloud of your choice. It's going to use this Kaleido bridging technology as a forward and reverse proxy to communicate with managed services on Kaleido and then have those, P2P communications come back as well. So we will go ahead and you can do this one of two ways now. Within the context of a node, you can go ahead and click this Create Network Bridge option. Or if you go back to sort of the blockchain menu here, we have an apps and integrations section, and you can click on the dashboard and you can go ahead and create, this service from the security tab, within the apps and integrations. What we're going to do is we're going to be sending our transactions directly to node number 1. So what I need to do is I need to create this private stack bridge that has the same membership. I need to bind it to the same membership as node number 1. So to make this easier or to not screw up, what I'll do is I'll just create it through the context of node number 1 so that I don't even have to pick that membership. Okay, so we'll go down to alpha. Name of the deployment. What we're really doing is we're connecting a local bridge to a Kaleido managed bridge and ultimately then into the Corda node. So I'm just going to name this Nick's laptop because that's really what I'm connecting through. That's the proxy that's sending calls back into Kaleido. So we'll click finish, and this is a Kaleido managed service. So this is going to require application credentials, basic auth in order to securely connect to this endpoint here. So this guy will take 30 or 45 seconds to fully provision. And while he's coming up, let's go ahead and check on our nodes and see if they've fully initialized here. So we'll go back to our dashboard. We'll click on node number 1. We see that the private stack bridge is still provisioning. Let's click on our logs, and we see that it's loaded 2 core dApps, and it is running the P2P messaging loop here. So node number 1 is happy, and node number 2 is likely happy as well. So also loaded the core dApps and running the P2P messaging loop. So that's fantastic. We'll come back here and we'll just wait a few seconds for this private stack bridge to fully initialize. And now we're going to go ahead and make use of this connect network bridge button here. So again, this is just like any service or any node on Kaleido. It's protected with boundary security. So we need to create these strongly generated security credentials that we call app credentials in order to have that secure TLS connection. So I'm just going to call these alpha 123 since that's the membership. And Kaleido is going to give us a screen showing all of those details and all of the endpoints that we care about: username, password, embedded basic auth string, or base64 encoded auth header right here. What we want is we want a JSON configuration object that we're going to be able to use with our locally running version of the bridge so that it can securely connect back to Kaleido. This is going to teach our local service about the core endpoints. It's going to teach us about this server right here, this Kaleido private stack or private bridge server. And it's going to teach it about the basic TCP ports that we need to send these calls to here. So I'm going to go ahead and click this download config button, and this is just going to be a pretty simple JSON blob here with all of those endpoints I just alluded to. So here's our client. This is what we'll be running locally. Here's the server that we're trying to talk to. This is the Kaleido bridge hosted, the hosted one on Kaleido. There's the username and the password. And here's all the port mappings that we have here. What we're really concerned with is we're concerned with the port mapping to node number 1 over TCP. So this is what we will enumerate inside of our application here. Okay, so this is U0VC, saying that for my own memory. And then the local component, the executable, the binary that you want to run, like I said, it's a symmetric mirror of the service that's running on Kaleido. So you can go and click this download network bridge button. This will take you to a library. You can just grab the appropriate binary for your operating system here. I'm running on a Mac for context here. So, okay. So what we have here, this is the Kaleido, the local executable that I have running on my machine. So first what we need to do is we need to create an environment variable that's going to tell our local executable, our local bridge about that configuration file that we just downloaded. So we're going to call this tunneler config. And we're going to give it the path to where we grabbed that. I think it was U0V, I hope. Okay, it was. Okay, and now we can just go ahead and kick off this bridge. So this is now securely connecting back to the Kaleido hosted bridge. And when we send application calls, they'll get routed through this local bridge into the Kaleido hosted bridge and ultimately into our Corda node. Okay, so we've done that heavy lifting. The last thing we need to do is we need to create some usernames and some passwords for our authentication for our application to connect back to the Corda node. So we'll do that in the context of the alpha membership or node number 1 as well. So we'll go down here to the user management option. Go ahead and create a user. We're going to call this guy user number 1. I'm going to give him an arbitrary role called transactor. And then I'm going to just create my own password. You can also let Kaleido handle the entropy for you here on the password, either way. So we've created user number 1. We see an error message that it's got a role called transactor, but that role hasn't been defined. So let's just go ahead and create that role, transactor, and I'm just going to give it super admin root permissions there. So user 1 with an associated password that I created, this is what we're going to pass alongside our application here. Okay, so the last step, I think we've done all the heavy lifting. We've uploaded our core dApps into the nodes. We've created our Kaleido hosted network bridge. We're running our local bridge with that proper configuration. And then the last thing we want to do is we want to just drive the application here. So this is the RPC client that we got inside of that public GitHub library. So it's just an RPC client executable. You can grab the H flag to see the available methods. What we're going to be using here is we're going to be using the URL, pointing to localhost 40,031. We're going to be using the username, the password, and then we're going to enumerate a method inside of our flow, the issue method. So clear that again so we have some space. So we'll say issue-u is localhost 40031 -n is user 1. And let me move the Zoom thing again. And -p is password 1. I made a real strong password. Okay, so we should see some activity happening over here. This is routing the request into node number 1. So if we actually go and look at our nodes right here, we'll see that this right here, 5TQ is actually the ID of node number 1. And what it's prompting us for over here is to enumerate the ID of node number 2, our borrower in this scenario. So let's go back into the Kaleido console and let's make sure that we have these strings properly identified. So 5TQ, we expect that to be node number 1, and then we want to look up node number 2. So here's node number 1, 5TQ, and now we want to switch to node number 2, and we see that its ID is LMK. So now we just need to choose the integer that corresponds to LMK, which is number 1 in this scenario. So this is going to complete the entire IOU flow, about, I don't know, 20 to 25 seconds for each of the nodes to, sign that acknowledgement, send it to the notary, and then the notary return it to each node, and they can store it in their private state vault. So 23 to 24 seconds would be my guess for all of these hops to fully complete. And once they've completed, we'll have a transaction hash, we'll have an ID that we can use to do a more involved query if we want. So here's the ID of the transaction. So we can go ahead and copy this onto the clipboard, and then we can just call a query. So again, RPC, instead of issue, we're going to go query. We're going localhost again. We're going through the same route to node number 1, user 1, password 1, and then I to identify the hash there. I think I got that right. Yep, so that request came through, and then we'll just see a cleaner list out of who the lender was, who the borrower was, who the notary was in this scenario right here. So I looked up the transaction by the hash. We see the notary, the common name, and the IDs, and we see the value that we used in this flow, and then we see the lender and the lender ID, and the borrower ID as well. So how did we do? So I think we did that in about 20 minutes. So again, all I did was I went step by step through this documentation, the Corda Quick Start Guide. Again, every single person can sign up for an account on Kaleido. Don't even have to put in a credit card. You can use our free starter plan, or you can use our team plan, and you can experiment with this Corda functionality and or with the Ethereum functionality as well. So I see that there's maybe one question in the chat. So Maria, I'll give this one to Jim if Jim's on. Can we integrate Tableau as an API in the application?
Yeah, hey, thanks, Nick. That's a great demo. Not very familiar with Tableau. I'm going to assume that's a software as a service platform that gives you API to certain aspects of enterprise application development, just like Twilio. I assume the question is, can we call APIs from our decentralized applications? So typically, decentralized applications involving a blockchain has at least 2 parts conceptually. The part that runs on the blockchain layer in the decentralized nodes, and then the rest of them are just regular enterprise application backends and front ends. You can definitely call any APIs in the typical enterprise backend code and front end. But decentralized applications running on the blockchain typically do not allow you to call external APIs. This is by design because blockchain logic needs to be deterministic, so that whenever they are run on any nodes sitting anywhere in the world, they always turn out the same output given the same input. So by design, you're typically restricted on the things you can do, and calling an external API is not one of the things that you're allowed to do in that layer of the architecture. So if you have a need to consult an external data source as part of processing your transactions, you need to not pull data from inside, but send data from the outside. And usually that involves a architecture component called oracles, which is a name for a component that can fulfill these requirements and then send data into the blockchain layer on demand. So if you're interested in learning about oracles, there's an article you can find on our blog site that talks about Chainlink. Chainlink is one of the more well-known oracles designed by a company called Chainlink. So you can read about this and see how this particular oracle works under the cover. And that is just one example of using external APIs with a blockchain application.
Thanks, Jim. Looks like there's a couple others in the Q&A from Flavio. First one around the database that the Corda nodes are using. I think it's H2, but I'll leave these ones with you to give more details on that.
Yeah, you're absolutely right, Nick. The built-in database we have today running on the node, which is based on Corda OS, the open source edition of Corda. The built-in database is H2. So if you have a need for more types of database to be supported, like Postgres, for example, then come and talk to us. We're still in the process of onboarding Corda Enterprise version, which will bring you the support for other relational databases like PostgreSQL. And it's really easy to contact us once you are in the Kaleido console. Click on that question mark in the lower left corner, and you can open the ticket, and our support team will be very responsible to help you through this.
Thanks, Jim. Yeah, so I'll take the second question. Yeah, I did, Flavio, I did a very benevolent dictator centralized flow in this Corda example. I'll give the same response as Jim. Just reach out to us offline so we can learn more about your project and your use case and your requirements. And we can absolutely discuss and look at options to run this in a more decentralized way, similar to how the Ethereum networks are run on our business and our enterprise tiers as well. So what I will do, thanks for the questions, guys. Those are super useful. Yeah, so like Jim said, just use that question mark. You can reach out to us if it's of a technical nature. Just use the appropriate tag here. If it's a sales inquiry, just go ahead and use that tag as well. And this gets routed to myself and the broader team. What I'll also do is I'll put some email addresses into the chat here for folks to reach out as well. So you can always contact us at support@kaleido.io. You can reach us at sales@kaleido.io, and you can reach me directly just at nick.gasky@kaleido.io. So choose any of those routes if you want to get in touch with us. Okay, another question in the chat as well. Any protocol to support interoperability of different blockchain platforms? Ooh, good one. I'll leave that with Jim. I guess as you could see, you know, we do support multi-protocol. We have Enterprise Ethereum, and we have Corda on the platform. Within the Ethereum bucket, we also have Geth, and we have Besu and Quorum, soon to be just under the banner of Quorum. But maybe Jim, you can speak about potential down the road interoperability options.
Yeah, sure. So interoperability is a pretty wide topic. Generally, that means getting transactions that are happening in one blockchain to be consulted on when another transaction is happening on a different chain, and have the two separate chains be able to validate and verify transactions mutually. I said it's a very wide topic because solutions for interoperability is a wide range of architecture choices. You can have a centralized component that's coordinating the transactions on both chains, listening to events, and then making sure when one transaction happens in one, the corresponding transaction happens in the other. So obviously this kind of breaks the decentralized nature of the blockchain themselves, because now you're relying on a centralized component to do the critical coordination. There are other techniques where you can do the transaction validation on the blockchain code themselves using smart contract. It's more complex to accomplish a more decentralized solution for interop. And there are many other ways to achieve interop. I'm not sure this attendee, Duke, whether you have a particular need and scenario in mind. Kaleido today supports Ethereum variations plus Corda. We do plan to support other popular enterprise blockchain protocols down the road. And interoperability is something that we have been working on in the background as well, because eventually our customers will have a need for this as they onboard more and more consortiums that tend to cross different protocols. So if you'd like to discuss more details, feel free to contact us off-chain.
Great, thanks, Jim. Okay. So I think that's it for the chat and the Q&A. Thanks everyone for those great questions. Also, thanks for taking some time out of your day to attend this and to see how Corda works on Kaleido. I'll reiterate that it is free to create an account and to go through the same steps that I just did. And you can always contact us using the features that we showed or using any of those email addresses as well. So this is recorded. You'll receive this recording and you can view any of the past recordings on Corda and or Ethereum on our YouTube page. And stay tuned for announcements on future topics on upcoming Tuesdays. So thanks again. Hope everyone stays safe and healthy and have a great remainder of your Tuesday.